We'll see today some part about inheritance, then the two different methods of using inheritance, that is easy relationship and has a relationship. It will be seeing these two, and then we'll be covering the interface today. So basically, when you try to implement inheritance, you have seen 5 different types in last lecture. And we have seen programmatically how to use extends keyword while inheriting the properties of one class to another class. So there are 2 different methods from which we can achieve inheritance. Is basically when we try to implement a program is through is A and has A, right? So this represents the relationship between the parent and child, right? So the relationship between 2 classes here you can see as an example. First class we have as a programmer, right, which has a variable named as bonus, and another has as an employee which is holding its salary, right? So it will be dependent. Is a relationship between programmer and employee, that if he's having a salary, he'll be having a float as a bonus, right? So this will be your integer part with how much percentage on the salary will be the bonus, right? So it is a kind of dependency. It is a must, right? So here it means that a programmer is a type of employee. So programmer is the subclass and employee is the superclass. So you can say that the relationship between these 2 classes, the programmer and employee, you can call it as programmer is a relationship with employee. So it is called as programmer is a employee. So it is a type of employee for programmer. Now let's see what is has a relationship, right? Basically, if you see a class has an entity reference, always a reference list. So that reference you can say it as has a relationship which represents aggregation, right? So is A you may call it as inheritance, and has A you may call it as aggregation. Right? Now consider a situation same as of the employee, which contains you can say different attributes or information of an employee, such as ID, name, email ID, right? So it will be containing one or more objects, right? Whereas we'll be having an address as a class which contains its own information, such as city, state, country, zip code, etc. Right? So we'll be having 2 different classes as employee and another class as address. Right? Now, what is the use of aggregation? How to decide when to use is a relationship and has a relationship? Now, you can see here code reusability can be achieved by aggregation. Now, this is one of the main aspect of using inheritance, right? If I'm going to use the same code with some different perspectives, right, by changing the values just at the runtime, I can use the same code again and again with different parameters, with different attributes. Right? So this can be achieved by using inheritance. If you're going to use inheritance, there will be 2 different categories, as is a and has a relationship. Right? So inheritance should be used only if the relationship is maintained throughout the lifetime of the objects. That means that kind of relationship will not be changed between the objects in a program or in an application until those objects are destroyed from the memory, right? Or they are being unused later on. Till then, you can say that is a relationship can be into existence. Otherwise, if you're going to change the values, or you can say the relationship of two or more different objects for each iteration, then you can go for aggregation, right? Now, if I consider these 2 classes as employee and address, in such case, employee will be having an entity reference of address class, right? So what do we call it as? A relationship of employee has a address. Now here address will be a class, not just holding an address, but we will be splitting it into different four parts, as address might contain city, his or her state, country, and zip code, right? So depending on these attributes or the information what address holds on, we'll be calling upon that address into employee, right? So basically, again, I say that aggregation will also be used for code reusability. So firstly, we'll see by creating two classes. So first we'll create address. So address class will have its attributes named as, we'll see, class as address. Then we'll take the attributes as string for city, state, and country. Let's take a parameterized constructor. Then we'll define it by using this keyword. Yes, save this. We'll take one more class which has the attributes of employee class. So we have here as integer of ID. Then let's take a string as name, and we have a class as address, right? We'll use a display method. Call those attributes from the address class. And we'll go for main class to create objects. Create one more address object A2. Create an object of employee class also, so that it may be accessible from this class to another as employee class. Then we need to pass this parameter, right? So that it can call those city, state, and country. So A1 here. And similarly for second object of E2, and then display it. So E1 dot display and E2 dot display. Let's save this with employee.java. Okay, now let's execute it. You can see here the attributes. These are the attributes from address class, which is being accessed by EMP class, right? So what we do is we create a relationship between employee and address, right? So that aggregation can be achieved, right? So aggregation basically can be also used to reduce your code, and aggregation is basically used when there is no is a relationship between your objects, right? So inheritance should be only achieved when achieved in terms of aggregation when there is no easy relationship between it, right? So this can be achieved